Hey everybody, I hope you're doing well today. I wanted to record a video where I went over the solutions to the FRQ problems. Typically I'm not going to be giving 4 FRQ problems in one assignment, but what I wanted to do is I wanted to just give you maybe a few different types of problems that you see on the AP exam and kind of archetypes, problems that are very representative of what you might see on the AP exam this year. So the first problem that we looked at was actually a problem from 2006. Right, so AP 2006. I prefer to show you the actual AP document rather than what you're seeing on your assignment or rather than what you're seeing on the PDFs that I'm posting, because these actually give you information that is exactly identical to what you're going to see on the exam. So you'll see a little bit more information, and formatting wise it just looks a little bit better than what you see on your assignment. So this is from 2006, so it was problem number 3, and it introduces a class called customer, right? And if you read through these details, what they tell you is that a customer has a name and an ID number, so similar to a student, right? Name and ID number. And what we want to do is we want to sort these customers in some way, and the way they say they sort the numbers are first by their first name alphabetically, and if they have the same first name, they sort them in order by ID, right? So the lower ID numbers occur first, whereas the higher ID numbers would occur later. So that's how we're going to sort these customers. And the first thing we have to do in part A is we have to create a method which tells us which customer occurs first. Okay, so they give us 2 customers and we have to say which one occurs first. Now, the return type here is an integer, right? Instead of the return type being something like a customer object, you say this customer is first, they just want an integer. What they say is if it returns 0, it means the 2 customers that you're comparing have the same name and the same ID number. But if it returns a positive integer, that means that the implicit parameter occurs before or occurs after the explicit parameter, and vice versa. If it returns a negative number, then the implicit parameter occurs after the explicit parameter. And what we can see here is they show us here, right, here's C1, we have a customer Smith 1001, we have another customer Anderson 1002, and we have another one Smith 1003. Okay, so some matrix references here, Smith and Anderson. Alright, so what they do is they compare C1 to itself. So C1, compare customer C1, returns 0, right? Because it's the same name and the same ID number. Alright, if I compare C1 to C2, it returns a positive integer, right? Because Smith alphabetically occurs after Anderson. So this would return a positive integer. Whereas C1 compared to C3, you can see they have the same name, Smith and Smith, but 1001, that ID number is lower than 1003, so the implicit parameter would occur before the explicit parameter, so that's a negative integer. Okay, so this would return a negative integer because C1 occurs before C3. Alright, so this is the method that we need to implement. So a lot of logic going into this, right? A lot of if statements, things like that. So when we look at the solution, right, what we can see is the first thing I'm going to do, I'm going to expand this a little bit. Alright, the first thing I'm going to do here is I'm going to compare the names of the 2 customers, and I'm going to store that in a number. Okay? Now, if the 2 customers, right, have the same name, then the compare to method is going to return 0. Right? And if they have the same name, then I have to compare their ID numbers. Right? But if they have different names, then I can already order them. So what I want to look at is if the names are different, that's what this logic statement says. If this number right here returns something other than 0, it means their name is different, I can just return the number, because the compare to method from the string class will automatically return a positive integer or a negative integer accordingly. Right? Whereas if the num is not equal to 0, so this else statement here, this means that they have the same name, then I compare their ID numbers, and I'm going to return the ID number of the implicit parameter minus the ID number of the explicit parameter. So C1, right, is this. So if this occurs before, right, if C1 occurs before C3, like in our example here, it'll return a negative number, because 1001 minus 1003 is negative 2. Right? If it's the other way around, then it would return a positive number. Okay? So this is how we can do this first method. All right, the second method, if we look at part B, right, they have two different lists, list 1 and list 2. And what we need to do is we need to create a new list, or they tell us the new list is already created, called result, but it has all null elements, right? All the elements here are empty, and we need to fill it. But the new array also needs to be in sorted order. The list 1 and list 2 are already sorted appropriately. So all I have to do, what they explain here, is I compare the first element in each list. And whichever one goes first, in this case Aaron would go first, I put Aaron in the first spot on result. Right? Then I move on and I compare Arthur to Baker. Well, Arthur would occur before Baker, so now Arthur goes in the second one. Now I compare Burton to Baker. Baker goes first, so Baker goes here. Now Burton and Burton are both the same customer. And they explain up here that customers, we can't have two of the same customers as elements in here, right? So I can't put like Burton and Burton in here, right? Every element has to be unique in my result. So here Burton is the same, so I'm going to add Burton in the fourth spot, but I'm also going to now move forward because these two Burtons are the same. I'm going to move forward in each list. So I'm going to compare Burton to Dillard, this new Burton with a new ID. So Burton becomes before Dillard, so Burton goes into the fifth spot, and then I compare Dillard to Franz, and Dillard goes in the sixth spot. So we can see here is our resulting array. So in order to complete this method, right, I have the prefix merge, and we can see that we have two lists, list 1 and list 2, and then result is list 3. So I need to keep track of each index for list 1 and list 2. So I initialize those to start at 0. And then I'm going to write a for loop that's going to go into each element of result one at a time. Because I want to fill this element, I want to fill this spot, this bin in result. So I go one at a time. And again, I use the compare customer method that I implemented in part A to compare the two customers. If the element from list 1 goes before the element from list 2, right, that would mean that num is less than 0, then I'm going to add the element from list 1 to result, and then I'm going to increment, I'm going to move to the next element in list 1. If instead the element from list 2 should go before the element in list 1, like in our first example here with Aaron and Arthur, then I'm going to add the element from list 2 to result, and then I'm going to increment the index controlling list 2. Lastly, if they have the same element, like I did here with Burton, right? Burton 3911 shows up twice, right? In this case, I'm going to add Burton to my list, but I'm going to increment both indexes so that it moves on to the next customer in each list. And at the end of it, I don't need to return anything because it's the void method. So you can see here, public static void prefix merge, it's void. So I don't have to return anything because what I'm doing is I'm changing this result parameter that they've given to me. So that's the action that I'm performing here. Right? So that one was from 2006. It was problem, let's see, what problem number was that? Problem number 3. So if we look over here in the scoring report, problem number 3, the average score was 4 points out of 9 when we're grading this. So 4.0 out of 9, you can see, was the hardest question on this exam. But in general, 4.0 out of 9 is not too difficult of a problem. It's about average. 4 out of 9 is about average for these nationwide averages. All right, let's look at the next problem. The next problem, oh, you know what? Was I looking at the wrong one there? Oh, I was looking at 2004. Okay, so 2006, problem number 3, 3.47. Hardest, oh, not the hardest problem. Problem number 4 was a little bit more difficult for this one. 3.47 is a pretty difficult problem. So 3.5 out of 9 points was the national average on that one. Okay, so let's look at the next problem. The next problem had to do with PR 2004, which is a personal robot. And what it does is it cleans up a hallway. So these numbers here represent the number of items that the robot needs to clean up from the hallway. Right, and they show how this method, which is going to be, that we're going to implement, which is cleaning up the entire hallway. But before we get there, we first look at this robot class, and we can see that there are 3 instance variables: hall, position, and facing right. Hall is represented here, right? It's the actual number of elements that need to be cleaned up, right, from each position in the hallway. This abbreviation, POS, is the position of the robot in the hallway, and facing right, it tells us whether the robot is facing right or not. If it's true, it means the robot's facing right. If it's false, it means the robot's facing left. So we need to implement these three methods here: forward move blocked, move, and clear hall. So the first one, forward move blocked, right, what we can see is if it's facing right, like it is in the example up here, and it's at the very end of the hallway, which is what this means, position is equal to hall.length minus 1, then I'm going to return true because I can't move forward, right? It's the end of the hallway, right? If it's facing left, which is what this Boolean means, right? Not facing right means it's facing left, and the position is 0, in other words, it's all the way at the beginning of the hallway and facing to the left, then its forward move is also blocked, so I return true. Now if each of these cases return false, each of these conditions return false, not return, but evaluate to false, then I'm going to return false because that means that I'm in some position in the hallway where I can move forward, either facing left or facing right, and I can move forward, so I return false if these first two conditions don't evaluate to true. Alright, so that's forward move blocked. The next method is move, which just defines one move. Now they tell us that there's three conditions here, or three actions that need to be performed in each move. Right, the first thing is if there are any items on the current tile, then one item is removed. So that's what our first if statement does here. It says if the hallway at the current position is greater than 0, it means there's something that the robot needs to clean up, then it's going to remove one item from that position. In addition to that, if there are more items on the current tile, then the robot doesn't do anything basically. Okay? But if there are no more items on the tile, and if the robot can move forward, it advances to the next tile in the direction it's facing. Otherwise, if the robot cannot move forward, it reverses direction and does not change position. So the first condition here is it says if there are no more items on the current tile. So we can see here, if the hallway at the current position is equal to 0. So there's nothing else for it to pick up. Then, if the forward move is not blocked, I'm going to move it forward. But that depends on which position it's facing. If it's facing right, then I'm going to increment the position so that it moves to the right 1 unit. If it's not facing right, so my else here means that it's facing left, so I'm going to decrement it so that it moves 1 to the left. Okay. Otherwise, right, from my original if statement here, if forward move blocked, this is saying otherwise. So now the forward move is blocked. If it's facing to the right, then I'm going to turn it around and face it to the left. If it wasn't facing to the right, it means it was facing left. I'm going to make it so turn it around so it does face right. Okay, so a lot of logic in here, a lot of different conditions in here. The important thing is just kind of take it one step at a time. They outline it here, 1, 2, 3, A and B, so we can just follow through and kind of check off the box for each one. The last one, part C, is implementing a method called clear hall. And if we look at clear hall, what it says is, right, it wants you to count the number of moves, right? That's one of the conditions in here. And then it also wants you to make sure that it continues to clean the hallway until there are no items left. So the nice thing about this is there is a method called hall is clear, right, which will tell us when if it reaches a point where there are no more elements to clean up. So I can create a loop that says while the hall is not clear, then I call on move and I increment num moves. So this is going to keep calling on move one step at a time until it cleans up the entire hallway. And at the very end, I just return the number of moves, right? Because that's what it asks to do here. It asks us to return an integer in the number of moves. All right, for this one, this was problem number 4, I believe. Yeah, problem number 4. And for this one, problem number 4 was a 4.37 out of 9, which is about average, maybe a little bit on the easy side. 4.37, but you can see overall this exam was really high scores. This was the very first exam that they transitioned to Java. Originally they were doing C++ and they transitioned to Java, so the exam was not really difficult. You can see as we go on year after year, these scores get lower and lower until about 3 or 4 years ago they realized the test was getting too hard and they made it easier again. But in general, these tests around 2004, the scores were really high. Alright, we're going to skip forward to 2011 now. 2011, problem number 1, they have these sounds, and what it is it's an array of samples that's basically measuring the decibels over time, right, of this sound. And what they want us to do is they want us to implement a method called limit amplitude, which basically says if there is a certain point in the sound clip where the decibels get too high or too low, then it changes them to that specific limit. So they give us a limit, and they want us to change that, change all of the specific instances where that goes beyond the limit to the limit. So if we look at the example here, right, they give us that the limit is 2,000. So these ones, these samples that go over 2,000 get clipped down to 2,000, and these ones that go over the negative 2,000 limit, they get clipped to negative 2,000. So I'm going to go through this one element at a time, and I'm going to check it to see if it's beyond the limit. And if it's beyond the limit, either the positive or the negative limit, I'm going to change it. So, and then I also have to return the number of changes that I have. So you can see here, int is a return type, so I create a local variable, right? Num changed equals to 0. And I'm going to write a for loop that goes through each sample one element at a time. And if the sample is less than the negative limit, then I set it equal to the negative limit and increment num changed. If the sample is greater than the positive limit, then I set it to the positive limit and I increment num changed. At the very end, I return the number of changed. All right. Whoops. Part B for this one was called trim silence from beginning. And what we can see is if there is a sample that looks like this, where there's a bunch of zeros in the beginning, it's going to trim those zeros from the beginning. So the way that I do that is I set I equal to 0, and this is going to count the number of zeros that there are in the beginning. So while this dot samples at I equals 0, I increment I. As soon as I hit something that's not equal to 0, it stops the while loop. So it's only going to count the leading zeros here. And then what I do is I create a new array. Right? My new array has samples.length minus I elements, and then I just copy the original array. You can see here this.samples. Right? I copy the original array, all of those elements, into my new array. But they're all going to be offset by 4. So you can see the original element was 4, now that's index 0. So that's why here I have j plus I, because it's offset by however many zeros I trimmed from the beginning. And then at the end, I just set samples equal to this new sample array that I created. For this one, that was problem number 1. That one was a 5.29. So really high scores in general on this one. So we have to look at specifically how these were scored to figure out how they were, how students received the points. But in general, if we see something like 5.29 on a problem, that means that that was, for AP standards, a pretty easy problem. Okay? So last problem was 2010, problem number 3. I think this is very representative of a type of problem that you'll see on the AP exam. They have a few different problems that are similar to this, where you're looking at an array and you're trying to determine some sort of property about the array. So in this case, the property that we're looking at first is it a level trail segment? In other words, it doesn't go up too high or too low. It's like pretty level for a hike. So what we can see here is for a trail, they give us an array called markers. Okay, and it's an array of integers. And what we're going to do is we're going to go through each marker and we're going to compare it to the min and the max, and we're going to figure out if it's level, quote unquote. So the first thing I do is I keep track of the minimum, I keep track of the maximum, right? And then I write a for loop that's going to go through every element in markers. So if we look at, here's an example one here, right? So if I look at each marker, 100, 150, 105, 120, each one at a time, I'm going to determine if that's my minimum. And if it's my new minimum, then I keep track of that. I'm going to also see if it's greater than my current maximum, and if it is, then I'm going to keep track of that. And at the very end, I'm going to compare my min and my max, and if it's less than or equal to 10, then I know it's level, so I'm going to return true. If it's greater than 10, it's not level, so it's going to return false. So this is my first part for this one, is level trail segment. All right, the part B for this one is a method called isDifficult. And isDifficult is trying to keep track of if it's changing like up and down, up and down, up and down. And so what we want to keep track of is the number of changes in elevation. If it goes from positive elevation change to negative elevation change, that's a change. So we're going to keep track of those number of changes. and if it says if the changes in elevation are at least 30 meters up or down between two consecutive markers, then if it has 3 or more of those changes, it's rated difficult. So let me pull this over so we can see it a little bit better. So I'm returning a Boolean value. I'm going to keep track of the number of changes, and I'm going to go through each marker one at a time, and I'm going to compare it to the one after it. Since I'm comparing the marker to the one after it, you need to note here in my for loop, I stop one short of the last element. If I go all the way up to the last element, I'm going to get an index out of bounds exception. So what I check here is if the absolute value of the difference is greater than or equal to 30, then that's considered a significant change. So I'm gonna increment my num changes. Now I go through the entire array, and if I go through the entire array and there are 3 or more of these significant changes, then that trail is rated as difficult. So I'm going to return true if there is greater than or equal to 3, and I'm going to return false if there are less than 3. Alright guys, if you have any questions, make sure you guys comment on Google Classroom and we'll go over these. In general, like I said, I'm not going to assign as many problems, but this one, since it was our first FRQ, and I think there is a lot of different array problems, so I wanted to show you all those different ones that you can see. Then make sure you comment on Google Classroom with some questions. We have some office hours on Tuesday of next week. Tomorrow, I'm going to be posting some announcement videos about some recent changes that they're making to our school closure. So make sure you're watching those videos for tomorrow, and I hope you guys are having a good day.